Hello student, this video lecture is prepared for heat transfer subject for diploma student, and I will discuss the unit number 6, that is evaporation. In previous lectures we had discussed different types of evaporators. So in last lecture, at the end of the last lecture, I had discussed calendar type or standard vertical tube evaporator, which is also called a short tube evaporator. So in today's lecture, I will discuss the long tube vertical evaporator, 4 circulation evaporators, and if the time permit, we will discuss the multiple effect evaporation. So let us start the lecture. So this is the figure of long tube vertical evaporator. So it consists of long tubular heating element. So this is called a tubular heating element, incorporating the tubes of 25 mm to 50 mm diameter. So diameter of the tube is 25 to 50 mm and 4 to 8 meter length. So this length is high as compared to the other evaporator. So it is called a long tube evaporator. Then the tubular heating element project the vapor. That means vapor produced in this heating element is projected into the vapor space. So the upper tube sheet, that means this part of the tubular exchanger, is free, and the vapor deflector, so this is called a vapor deflector. That vapor deflector is placed just above the tube sheet of this heating element. A return pipe is connecting to the vapor space to the bottom of the exchanger. So this is the return pipe for the natural circulation of unvaporized liquid. That means some liquid is unvaporized. That unvaporized liquid is sent here. So this is called a return pipe. It is provided with inlet outlet connections for the feed. So this is connection for feed. Vapor to be concentrated in the tubes. Condensing steam. So steam is added here. So, and the outlet is provided here for thick liquor, and outlet is provided for vapor at the top of the evaporator. So this is the construction of long tube vertical evaporator. So in working, in this evaporator the feed enters at the bottom of the tubes, get heated by condensing steam, start to boil, part way up the tubes, and mixture of vapor and liquid issues from the top of the tube, and finally impinge or collide at high velocity on the deflector. So you have to enter the feed from here. The feed is transferred in this heating element and steam is condensed. So due to this, the vapors and liquid mixture is created, and this liquid mixture collide on this deflector plate. The deflector act as a primary separator and foam breaker. So it will act as a foam breaker or separator. That means vapor and liquids are get separated. The separated liquid enter at the bottom of the exchanger, and part of this liquid is taken out as a product. So this liquid separated is taken out from this pipe, and part of this is taken as a thick liquor, and remaining part is mixed with the feed. Okay, and the vapor produced in this vapor space is taken out from this vapor outlet. So this type of evaporator are generally used for foamy or frothy liquors. Foamy means the liquid which produce the foam or froth. For example, milk, or concentrating the black liquor in pulp and paper production. So in paper production, we are concentrating this black liquor which is used for the paper production. So both are having foamy or frothy liquids. That means it will having the liquid mixture like a foam. So that type of a liquids can be handled in this long tube evaporator. The next evaporator is the forced circulation evaporator. I had discussed about the natural and forced circulation. So generally in natural evaporators, the circulation is naturally, and in forced circulation we have to use the pump for the circulation. And another difference between these two is natural circulation evaporators, the velocity of that liquid is low, that is 0.3 to 1 meter per second. And in case of forced circulation, the velocity is slightly higher, that is 2 to 6 meter per second. And another difference is that the forced circulation evaporator is having smaller diameter tubes than the natural circulation evaporator. That means it should not be generally larger than 50 millimeters. So there is a evaporator which is called a forced circulation evaporator with horizontal external element. So these are having two constructions. One is with horizontal external heating element and another is forced circulation evaporator with vertical heating element. That means the heat exchanger, heating elements means this is the heat exchanger. So this, if you put the heat exchanger horizontally, it is called a forced circulation evaporator with horizontal external heating element. And when we put the heat exchanger vertical direction, then it is called a forced circulation evaporator with vertical heating element. What is the construction? So it is having external horizontal heating element. So this is external. That means this heating element is not placed in this evaporator body. It is placed in a outside of the body. It is also consist of circulating pump, separator, evaporator body with vapor outlet provided, deflector plate, outlet for discharge of the thick liquor. Okay, so this is called a deflector plate. This is the evaporator body. The vapor outlet provided here and the thick liquor outlet is provided here. So here also we can take the partly concentrated liquor here and remaining liquor or liquid is sent recycle back with the mix with the feed. Okay. So we will discuss now working. A centrifugal pump force. So this is the centrifugal pump which force this liquid through the tubes at a high velocity, and it is heated as passing through the tubes. So it is passing through these tubes due to the heat transfer by condensing steam. So steam is added here. So this steam is give the heat to this liquid and the boiling does not take place. So boiling does not take place in this heat exchanger because it is under pressure. Then when you are sufficient static head, that means you have create a static pressure or head, then it will rise through the separator and then that solution is become superheated. That means instead of boiling they are converted directly superheated. That means in the vapor form, and that solution is fed to this deflector. So again deflector separate the vapor and liquid, and then this liquid is returned in this pipe and part of that liquid is taken as a concentrated liquor and remaining part is again mixed with the feed, and the same procedure or same cycle will repeated here. So the working of horizontal and vertical is same. Instead of Here horizontal tube evaporator, horizontal external heating element is provided, that means exchanger, and instead of here vertical tube exchanger is provided. That means working is same. You have to feed the feed solution here, you have to pump through this, it will go through the tubes, you have to add the steam, then solution becomes superheated. Superheated means it is boiling above boiling point, it is called a superheated. Then it is fed to this evaporator body. So this is the deflector. Deflector is nothing but just a one plate, metal plate, that separate the vapor and liquid, and concentrated liquid is taken out from here and remaining part is recycled. So this is the working of both evaporators. So what are the advantages of the forced circulation evaporator? High heat transfer coefficient is obtained. Then positive circulation and close control of the flow. That means there is no leakage and we can control the flow closely. That means according to your norms. Whenever there is tendency to form a scale deposit salt, we can use the forced circulation evaporator to prevent the excessive deposit due to the high velocity. So if you are dealing with the salty liquid or scale forming liquid, so due to the higher velocity, this liquid containing salt that does not deposited on these tubes. So for that purpose also we can use this forced circulation evaporator. And the residence time means how many times this liquid is remain in that evaporator or in the tubes is low. That means 1 to 3 seconds due to the high velocity. So heat sensitive material can be handled effectively. Heat sensitive material means the material which is decomposed by heating, that means pharmaceutical materials or some food product. If we give the heat, additional heat to that substance, it will decompose or it will lose their chemical structure. So that type of a liquids is called a heat sensitive liquids. So that liquids also can be effectively handled in this forced circulation evaporator. So these are the advantages. And what are the main disadvantages of this forced circulation evaporator is it is having high pumping cost. So the pumping cost, that means we are added pump here, so the pumping cost is high because we are dealing with the viscous liquid, and whenever we are dealing with the viscous liquid, the pumping cost of that equipment or evaporator is high. And what is the application of this evaporator? It can be used for a crystalline product, that means product which form the crystals, viscous, salting, scaling, corrosive, foaming solutions. So this type of solutions can be handled in this forced circulation evaporator. So here I want to conclude this lecture. So today's lecture I had discussed about the long tube vertical evaporator construction and working and the application, and then we had discussed what is the difference between natural and forced circulation evaporators, and after that I had discussed forced circulation evaporator with horizontal heating element and vertical heating element. So thanks. Remaining part we will discuss in the next lecture.